everyone. I think we should get going because we're already kind of 10 minutes late, 10 minutes behind schedule, and I'm sure there's going to be a lot of discussion around the topic we're talking about this morning. So today there are two sessions looking at cryptocurrencies, blockchain kind of stuff. This one is more of a deep dive, I think, sort of level setting, and then this afternoon is thinking about business opportunities around blockchain. Now, I've been in a number of conversations and meetings, a bit like this, talking about business opportunities around blockchain, and what tends to happen, and I think maybe it's because of the audience, is people kind of get a bit carried away and start sort of saying, well, you can do everything, you know, it solves world peace and all this kind of stuff. So, and whilst I think there are huge opportunities, there's a lot of interesting ideas around blockchain. I think it's really important that we ground ourselves in what some of the principles are, what blockchain technology does or doesn't do, and so really this morning's session is about doing that kind of level setting. It's helping us all to, when we have a broader discussion this afternoon, we're actually coming up with ideas that make sense in the context of what we're talking about. So that's the objective this morning. We've got two fantastic speakers here who are both. Oh, no worries, no worries. We've got two great speakers here this morning who are playing right at the centre of this whole kind of area of innovation. Vitalik from Ethereum, who is. So we've had some discussions, or there's been reference to the fact that Bitcoin isn't really where the interest is. Bitcoin had kind of created the idea in the first place, and actually some of the ideas from Bitcoin can kind of be taken and used in a broader context, not for a point solution, but sort of in a more generic way. So Ethereum are, I'm sure you'll talk to this, but Ethereum are building a platform on which some of these ideas can be explored in the future, and Vitalik Vitalik's the founder of that, and he'll talk to us about that shortly. And then we have Preston as well from Eris, who are operating in a similar space. I mean, he'll tell us more about his service. They're kind of working with Ethereum as well.
Not quite.
Well, on top of Ethereum,
we have our technologies to run.
Yeah. Anyway, I'll let you talk to what you're doing. But let's hear them speak for. Well, we've got quite a bit of time, about an hour and a quarter. So we'll hear them talk about what they're doing, some of these ideas, and then at the end have a debate around, do we believe this stuff? How does it actually work? What are the key characteristics? Hopefully to set us up for the discussion this afternoon. So Vitalik, over to you.
All right. Thank you. So should I stand up at all, or?
I think it'd be helpful if you could just.
Yeah.
Keep it back.
By the way, so what's this whole blockchain on Bitcoin thing? You guys should sometimes go on the Bitcoin Reddit and see what the people there think of all that. Let's say that even once, you get about five threads calling you the devil sometimes, depending on how important you are. So it's not good. So my presentation here is I'm going to try to talk about at least the concept of blockchains from my perspective and what I see blockchain as potentially being able to do. So the way that I think of at least Ethereum, the project that I'm developing, is just in simple terms, it's a magic decentralized computer on which you can run programs and those programs execute. That's basically the simplest way of describing it. So actually, I put the word distributed there instead of decentralized. That was actually a mistake that I forgot to correct. So I suppose this is one of those linguistic misconceptions that people have sometimes. Like, people sometimes talk about blockchains as being distributed, and sometimes people try to make a distinction between distributed and decentralized. So I prefer not using distributed with regard to this kind of technology yet. The reason basically is that distributed generally implies that things are being split up, kind of in the way that distributed Tor networks work, in that the effort is kind of distributed across the entire network. Blockchains don't work that way. They don't distribute anything. Everyone processes every transaction. It's massively replicated. So the distinction that is important, though, is this question of, is it politically decentralized and is it architecturally decentralized? So architecturally decentralized would be, okay, your data is stored on Google, but Google will have 3 servers in 3 different locations that are doing backups internally in order to decrease the probability that everything will break at the same time. Politically decentralized is no particular organization controls it. So those are 2 different things that we kind of need to think about them separately. Next one, so what are blockchains? So next important point. So this is part of a schedule that I saw at Future Fest where I was presenting this weekend. And one of the presentations was entitled Blockchain, How Encryption Will Shape the Economics and Politics of the Future. Anyone have any idea what's wrong with that title?
It's hard to think.
Yeah. So cryptocurrency does not use encryption anywhere. One of those fun facts about Bitcoin and cryptocurrency in general, it's all about digital signatures. So in cryptography, encryption is the branch of cryptography that deals with how do you hide data. Signatures are the branch of cryptography that deals with how do you authenticate data, how do you prove that data was produced by a particular person, that it was signed off on by a particular person, and so forth. So blockchains are really all about the second branch. And it's not just a pedantic technical point, it's actually important because a lot of people in the blockchain space are simultaneously people who are interested in privacy. And blockchains by themselves do not provide privacy, they provide transparency. Now, of course, there are ways that you can use blockchain technology in order to increase privacy, but you have to be a bit more clever, and then there's other cryptography that has to be involved, and it's kind of tricky. So blockchains, decentralized database, decentralized computer, and the key properties that they have are, first of all, managed by thousands of nodes, controlled by thousands of users at the same time. So there's no single point of trust, there's no single point of failure. It's not a computer controlled by Amazon, it's not a computer controlled by Google, it's a magic decentralized computer. You do not need to think about who's controlling it. It runs and it's going to continue running. There's no particular group such that if that group fails, the computer stops running. So I guess you can think of it as being a kind of sort of bottom level basic infrastructure that's intended to be extremely reliable and sort of transcend any particular organization. And also all execution fully transparent, history is recorded forever. So, if you have this blockchain, then anyone can launch a decentralized service or some kind of program onto the blockchain. And once it's launched, it just sits there and it continues doing its function pretty much forever, pretty much for as long as it stays on there, for as long as any user cares about it. So that's the basic idea here. So it's a way of executing a program in such a way that, first of all, the execution is fully transparent. Anyone can independently verify and trace the execution and make sure that it was done correctly. And the execution is guaranteed to happen in some particular fashion. So that's roughly how I think about them. And of course, it has weaknesses too. So one weakness is that computation and transactions are much more expensive. So a blockchain is once again, it's not distributed, it's replicated. Every single computer in the network processes every single transaction at the same time. Now, there is upcoming technology in blockchain scalability that will help mitigate the problem. So it's actually not something that we can expect being the case in the medium-term future. But even still, in order for the thing to be secure, there's always going to be some kind of overhead of at least a factor of, say, hundreds of thousands. So, if all you're doing is just a single transaction that says, hey, here's a financial contract. This financial contract evaluates to this simple arithmetic, and if the simple arithmetic goes one way, it sends money to this guy, and if the result is something else, it sends some money to that guy, then the amount of computation involved is so tiny that capital is not a problem at all. Same reason why people write software in Python instead of writing it in assembly. Sure, Python's 1,000 times slower, but there's always nice other advantages, and sometimes those other advantages actually win it. But of course, if you're going to be doing any kind of extremely technical computation learning, or whatever else you need entire access service for, blockchain is probably the best place for it. So, and then of course, no privacy by default. So that's roughly, I think, the set of technical properties that you can think of blockchains as having. Now, there's different types of blockchains. So when I talk about people running decentralized services or these decentralized programs that sort of live on the blockchain and talk to each other, that's more talking about Ethereum specifically. So, and then there's a bit of a continuum here. So Bitcoin is an application-specific blockchain. It's meant to be there only for a specific purpose. And it's just a database, and the only operation is if you have some quantity of Bitcoins, then you can send that quantity of Bitcoins to some other address. So in Ethereum, on the other hand, the system is what's called Turing complete. You can do just about whatever you want on it. Of course, within limits. Like, you do get charged transaction fees that are proportional to the quantity of space and computational resources that you consume, but within that, you can theoretically create any kinds of programs. You can create financial contracts. You can create things. You can put data on the blockchain. You can even have programs that do things with the data, and particularly programs inside of Ethereum can talk to each other. So this is probably perhaps even the first time in the world where we've had a platform where you actually have the ability for company A to be running a service on the system, and for company B to run a service on the system, and for company A and company B's service to have perfect 100% interoperability, and at the same time have both company A and company B have the assurance that the whole thing is trustworthy from their point of view. So it's the benefits of blockchains, I think, add up, particularly in those cases where you actually have a whole bunch of interactions, where you have, it's not just something that's done internally to one. Yes.
It's allowed to do a question.
Yeah.
Okay. When you say it's complete interoperability between applications with Ethereum, and then immediately I think, okay, how about the API economy where everybody's talking about and all these applications? How does that relate to each other?
Right.
Conceptually?
So generally speaking, if you have some kind of service, that service, people can talk to a service from the outside, or computer programs can talk to a service from the outside, right? And so if you're looking at something like I guess simple example, something like Bloomberg, right? What they do is they provide financial data. So generally, they have an API, and you can access, and people can access it. Here, if there would be a provider of financial information that would be providing it onto the blockchain, then they would then the way that the program on the blockchain would be designed is that they would have a sort of administrator key that they can use to push data in. And then anything else that's inside the blockchain can just access that information, because stuff on the blockchain can talk to other stuff on the blockchain. And now, if you are something outside the blockchain and you want to use information from something inside the blockchain, then there is an API. On the bottom level, the way it works is that you either maintain a node yourself, or you talk to a node and you just read the database yourself because you have a copy of it and you can see what's going on. But from the developer's point of view, you basically see it's very, very similar to talking to servers. There's an API, you use it. So why use it? So general set of properties that it has. I mean, it's first of all, it's an excellent base layer for these kind of interoperable ecosystems of services. So if you want to have financial data, and then you want to have smart contracts that use that financial data, and then you want to have, or even something in the Internet of Things where you have a whole bunch of different objects, and they might even end up having relationships with each other. You might even want your this example, you want your dishwasher ordering extra supplies for itself and so forth. It's a situation where there's a need for a lot of interoperability, and so it makes sense if all of these different things are on the blockchain subsets, and it makes it easier for them to talk to each other. Next one, it's the thing that Bitcoin got famous for to some degree: resistance to governmental and corporate censorship. WikiLeaks got, at some point back when payment processors and banks were shutting it down, it got the majority of its donations from Bitcoin. So this is an advantage. Now, of course, if you're someone from a traditional financial company and you're just not comfortable with interacting with a platform that has this property, then you can always make a private blockchain. So, if you want, you could always get together with a cabal of 16 companies or whatever and form. Yes. If you want consortium. Yes. if you want to get together with your happy fluffy friendship club of 16 companies and just run a blockchain between the 16 of you and only allow things from within a particular group of people, then you have the ability to do that. So that is also an option that exists. Zero upfront cost solution for secure applications development. So, it's one of the nice things about building on something like Ethereum is that if you build on top of just basic centralized internet infrastructure, then there's a lot of pieces that that's been built in the 1990s, and there's a lot of pieces that since the 1990s that we've realized are really, really important, like identity and authentication. So, generally, just about every sort of substantial web application that people make, you have to log into it and you have to sign up, and there's some concept of accounts. And so, if you're building your own thing, then you have two choices. One choice is, well, you just build your own system for that from scratch. And the second approach is, well, you just sort of you'll let people sign in with Google or sign in with Facebook. So I guess the sort of important question to ask here is, do we really want Google and Facebook being in control of our identities to such a large degree? So, there is this kind of political centralization problem, and we do need to think about it. And having things that are on the sort of very bottom level that all things rely on being decentralized is something that's valuable for that reason. And now, if you're doing things on a blockchain, then you can have identities be on blockchains for some reason. Now, of course, what that means exactly, you have to sort of unpack exactly what identity is, right? First of all, there's this public key cryptography layer. Somebody has a private key, and that key is sort of the information that controls their ability to use some particular identity. And blockchain platforms have cryptography built right into the bottom level. So it's you don't even need to think about the cryptography yourself. It's all sort of completely integrated. So yes.
And Vitalik, sorry, but like a lot of people get hung up on Bitcoin not being free. And when I try to tell them when a small company like ours would use zero upfront cost solution, where suddenly a small company can have as good a cryptographic solution as Google, and how really, innovative and disruptive that is, and combined with the first point of completely interoperable and zero upfront cost is how revolutionary that really is. If you go back to your example of Bloomberg, can you give an example of if Bloomberg were to have built with zero upfront cost on this kind of technology?
I mean, if there was zero upfront cost for building your own Bloomberg, then chances are, first of all, one thing we'd have every single national weather service in every country in the world probably using the exact same API to provide weather data, and so you could have like So imagine a completely globalized market for doing, any kind of insurance on weather. So this is something that was brought up in the morning. There's people that wants to do something. There's people that wants to hedge their exposure, and it becomes much easier to create a sort of decentralized platform. You can do that for anything anywhere in the world. Then financial ecosystem, I suppose. You could have feeds literally price feeds for literally just about every asset in existence. So I guess the benefit probably even comes in and more in the long tail and in the entire very large category of things that people don't focus so much attention on. Yeah.
So the whole zero upfront cost thing doesn't really play to me because you can't just get Bitcoin, you can't just get anything. You have to pay for those tokens in the first place. So. Right, I guess zero. Okay, zero. It's not quite zero. It's 50 cents. But first of all, realistically speaking, let's say you are going to create. First of all, if you're maintaining your own website, then at the very least you have to have some kind of virtual server that thing sits on. At the very least, that's $10 a month. And in my own personal experience, trying to maintain a website, chances quite often it just so happens that something crashes, it breaks, it shuts down, or whatever, and you have to personally go and you have to personally make sure that everything stays up and that everything works well. You might
go over some usage cap, and you get, and so forth. So meanwhile, now of course the question is, well, for those kinds of use cases, doesn't it make more sense to sort of just combine things and have a common computing platform? Well, yes, but it was hard to find a platform. Which was extremely trustworthy, and this kind of is, I suppose, a solution. So it's like in general, it's if you think about applications that have a very, very small number of users. So some that there's a couple that I like to think about is, first of all, there's this. There's at least a bot on Reddit, and there's a whole bunch of different. I'm sure there's some different startups for it. And what they specialize in is basically, I want to be reminded of something at some point in the future. Could be a few months, could be 1 year, could be 25 years. So, first of all, if you try and do this, and if you want to be reminded of something in 25 years, are you really going to trust a startup to continue existing in 25 years? Or are you going to trust a script on the blockchain that's going to keep existing for as long as the blockchain exists? So that's, if this then that is another one of those internet startups that's appeared lately. It's that basically, if some particular event happens, then automatically triggers some particular thing. Perfect thing that really should just be stuck on the blockchain somewhere. Document timestamping, even something as mundane as software update notifications. So I guess so as far as zero upfront cost goes, I guess it's those things, like making a service is, or making some kind of website that does something is moderately easy now. Making that service simultaneously have a really high reliability is harder. On a blockchain, well, the blockchain is more reliable than Google is. So you have that, you get that for free. That's one way of describing sort of benefit. So generally, people sometimes ask, what is the killer app for blockchains? And I mean, I personally was trying to search for one for quite a while now. But the thing that I've kind of realized is, it's first of all, what is the killer app for open source, right? It's not the sort of thing that you can really come up with a good answer for, because there really isn't one. Like, it's not something that, oh, hey, look, oh my God, here's this one place where this particular technology can just massively revolutionize everything. It's, you have some incremental benefits here, some incremental benefits there, some incremental benefits there, and once there's enough network effects all around, hopefully it'll add up, and hopefully the benefits will just sort of come more in the medium to long term. So, it's, if you have less than 1,000 users, it's probably going to be actually cheaper to pay transaction fees than this to maintain your own server. You get very high uptime. You get security primitives for free. Like, this basically is it, right? So it's really, quickly going through a bunch of practical examples. On the internet, there's this problem that, in general, data on the internet is really heavily dependent on other data. And problem is, if you put your data on a server somewhere, chances are that's managed by a company. Chances are that thing at some point is going to disappear. The company is going to go bankrupt, is going to get bored, or whatever else. And 49% of the links cited in Supreme Court decisions are broken. So, we have, the internet seems to be a place that just naturally encourages people to become very, very interdependent on each other. And when everything becomes very interdependent on everything else, reliability becomes extremely important. So, I think as we move from a web of interlinking data to a web of interlinking programs and software, and programs that use data, and programs that use data produced by other programs, technology like this is going to become important. Well, you can think of it as a software development platform with its own sort of built-in Internet Archive, except it's not so much an Internet Archive for a file, it's an Internet Archive for an entire program. So, things, in general, if you want to build, so there's several layers, I guess, of a blockchain-based ecosystem. The first layer is what happens at the bottom. So there's currencies, other digital assets. You have identity, domain name registration, another common use case, certificate validity, data feeds. On top, question is, what do you actually build on top of this, right? So the benefit that I see blockchains providing here is that, it's in a lot of cases, if you're trying to build any kind of platform, say some kind of smart contract system, and then there's always a whole bunch of different network effect problems. And the hope is that if we try to put some things onto a transparent ledger, then basically we're sort of creating what we can describe as being kind of base level public infrastructure that everything else can sit on, and that everything else can rely on, and that particular public infrastructure is just guaranteed to be there. So that's really, I guess, where I see what I see the other technology being. Any more questions?
Well, shall we?
Yes.
How are you doing with the presentation? Is that it?
I mean, I could talk about more, but I don't need to.
Yeah. Let's let Preston have
Sure.
do his slot, and then we'll have a wider debate. I think, because I think. Yeah. Let me just change it.
Turn the screen a little bit so I can see it. That'll be great. Right, so my name's Preston Byrne. I'm the CEO of Eris Industries, and we build a blockchain developer platform. And on the top of this presentation, I put a line, it's just software. Now, I'm from the United States, obviously, and this morning one of our speakers was saying, California is bubbly and futuristic and all the rest of it. And so I'm from a state called Connecticut. And Connecticut is known for insurance products, hedge funds, development and construction of nuclear weapons, deployment systems, and so it's not the cuddliest, and also witch burning. We did that. So it's not. So I don't want you to think that all Americans are all futuristic. Some of us are actually quite practical, and you can find them in Connecticut. And so London, it's called New England for a reason. So it's just software. Hold that in your mind for the rest of the presentation. So what we do is we took a derivative. We have made a derivative of the excellent technology that Ethereum has developed, and we've adapted it in accordance with that principle. So we recognized when we were developing applications on Ethereum that the quasi-Turing complete scripting language they incorporated into a blockchain actually allows you to go ahead.
I hate myself for asking this sort of question. But why did you call it quasi-Turing? Quasi-Turing complete. Is it complete?
Well, you want to go for that?
He said it was Turing complete.
Well,
there are limitations because you have to set limits on what computation you want to run, because otherwise someone will do something like set up an infinite loop, and you don't want that to happen in the system. So you set some hard limits so that someone can't totally destroy the system by putting on some malicious code. Eventually that code will stop executing. So it's effectively, for all intents and purposes, when developing an application with our blockchain or Ethereum, the difference is negligible between the two positions. So what we've done is we've developed a software platform. If you can script something and you can give it complex instructions, you can tell it what to do. And if you can tell the blockchain what to do, it means you can control any aspect of its functioning, including adding a block, including amending the way that it works, including who can transact with it, including who can mine it, anything you want with public-private key cryptography. And this, when you have a blockchain you can control, allows you to use certain of its aspects, not full decentralization, but the verifiability and the simple security logic to solve commercial problems and governance problems. And so what we're about is creating a platform that lets people do that all on their own. And the reason for that is because we look at the blockchain as something which automates process. If we look at Bitcoin and we strip away the currency and we strip away all of the politics, what do you have? You have a clearing and settlement function, which executes very reliably, time after time, again and again, and is very fault tolerant when it does so. That is a process. Currently, that process takes 3 days. With Bitcoin, it takes any time between 5 seconds and 6 minutes. So when you can tell it to do more complex things, you can apply a very similar mode of thinking in respect of other types of applications, whether it be a social network or financial, really anything you can write, you can now run, and you can furthermore run it on a blockchain. And so what we've done is we build tools that developers can make innumerable blockchains that follow these principles, millions of them is the work we see, to solve problems that they have identified with existing business process. So most people look at blockchains like this. This is the monolith from Arthur C. Clarke's, God, I can't remember the name of the film. 2001, The Space Odyssey. So a monolithic blockchain which is secured by vast quantities of hashing power, which everybody in the world uses, which stores all of the world's data, and is expected to be permanent and indelible for all time. And we look at it like this. Something which is repeatable, which is customizable, which can be designed, which can be tailored to a particular purpose to do a particular thing. And the reason for that is because everyone we've spoken to in the corporate world and in the governance world, this includes not necessarily just banks, this includes government agencies, not like three-letter agencies, but more like welfare agencies. Although the DoD did look at our website last week, so we're all a little bit creeped out by that. Thank you, Clicky. But basically, an international human rights organization, universities. So for research purposes, for anything else, this gives you a data structure which is extremely efficient at what it does, processing information back and forth in a verifiable way without having a server involved. But what you really need are these four aspects for it to be commercially useful. You need accountability. You need someone who can step in when something goes wrong. You need controllability. You need to be able to tailor it and update it over time on command as the facts on the ground change, and the structure of that application needs to change to match those facts. Repeatability. Once you have a process that you have identified in open source code that you have automated, let's say there's currently a company trying to do Lazoos, I think they're called. They're trying to automate Uber on a blockchain. You do that once, and you can do it 100,000 times. See you later, Uber. And it needs to be reversible in most commercial transactions. So you need to have that database behave in such a way, not that you're plucking the data out, but that the users of that system, when a particular transaction is deemed fraudulent, if your 2-year-old wires your entire savings to Tokyo, with Bitcoin, your savings are now in Tokyo, you're never seeing them again. With a blockchain that's run by a financial institution where they can intervene, they can reverse that transaction. So I didn't know you were actually going to say magical, so I apologize. This is not, but I think there is a lot of magical thinking in the blockchain space. It isn't. It is not magical. It is not an internet money machine. It is a frickin' database, as Vitalik and I have both said. And it is software, and it will do exactly what we tell it to do in exactly the manner we tell it to do so. So no more, no less. And so as a consequence, I mean, nobody really, one of the things we often get asked is, well, how do you use this thing? And give me some use cases. There are some people in this room who are very guilty of that. And well, it's a database. That's like asking, how do I use a database? And so what we allow is we think blockchains have the capacity to do all the things I've said they can do. And what we do is we make it very easy to generate blockchains which address a particular purpose. So to be perfectly frank, a lot of the futurist stuff you hear coming out of Silicon Valley is bullshit. The emperor has no clothes. It is software. I am appalled that the Californians have not looked at it like the software it is. And maybe it's a little strong, but I think there are aspects of blockchains that will bring about different types of social relations. It will not happen overnight. It will be very gradual and very, very iterative. So just, I'm not going to try to teach you to suck eggs here because you've heard a lot about blockchains. Basically, everything you do on the internet is currently run by a server somewhere else. Every single process, all you do is see what that server is telling you to see. Peer-to-peer architecture, we've been over it. With a blockchain, you have two components. You have the distributed component, which is the blockchain database itself, and then the rules on which you interact with that database. That's commonly known as the protocol. And then on the client side, you have the implementation and the user interface, which basically translates into English everything that's going on under the blockchain, because most people can't code. So now, why is this useful in a commercial context? Basically because a blockchain is a rule book. It is a book of rules for a particular data-driven interaction. You can track any changes which are made. You can verify that those changes have been made in accordance with certain write permissions, which are controlled by public key cryptography. And the really most interesting thing is that you can onboard someone almost instantaneously. If you have a rulebook and you have a process and you need to add a new user to that process, instead of, for example, throwing another server into the equation and making sure that they can look up, You simply give them a copy of the blockchain application, and you issue them with a key pair, which has a certain set of permissions. They download the blockchain, they're off to the races. So it's something where you can just onboard someone into a data-driven process by giving them a copy of the rules without enabling them to change the rules beyond the scope of their permissions. And what are those permissions? Blockchains basically run on 3 principles. Tell them what you're going to say it, and tell them what you said, which will be familiar to anyone here who's got presentation training. So tell them what you're going to say. This is what I call the transaction protocol. These will be the rules of the game for the users. In Bitcoin, this would be you can't spend a transaction when you don't have any Bitcoin to spend effectively, and the manner in which you go about spending it. The second one is the networking protocol. I want to spend Bitcoin. How do I communicate that message to the other users? I want to add a block to the end of this chain. How do I do that and communicate that to the other users? So what do all these actions mean in the context of the protocol? And then how do I say it to somebody else? And the third one, tell them what you said. This is agreeing the truth, the state of everything that has happened before, what has been said, who has said it, and is that record correct? In a context with a controlled blockchain, there are many ways you can do this. You could, there's this thing where you add up the sums of the Merkle hashes. So you know that with a blockchain structure, if you pluck a piece of data out, you have to recalculate all the data that's subsequent. So there are ways that you can verify that a blockchain state is valid by checkpointing that chain into bigger chains. Bitcoin, and particularly Ethereum, from our perspective, is extremely interesting because a distributed application will have a very substantial need to checkpoint against a heavy, sort of decentralized but centralized at the same time chain. And what has happened in the past determines what can happen in the future. You are putting your data to work for you by not supervising these processes because you know that the interactions, the way that you've specified them, someone will not be able to exceed the scope of their permissions once they have crossed a certain threshold and done all they can do. Put it all together, you get a rule book, that's the Code Civil. French law is crazy. But yeah, this is people can get copies of the system. We've been over that point. You translate it into English and bang, there you go. That's your blockchain application. So in cryptocurrency, the rules roughly look something like this. Rule 1, the transaction protocol, it's open to all, and this is designed to evade government controls, capital controls as discussed. Cryptocurrency rule 2 is that the architecture is distributed so that it's resilient to destruction or attack. Cryptocurrency pretty much got this one right from a commercial perspective. And then rule 3, competitive mining and awarding. So the security model is this proof of work that we hear about so often. So what happens is you have a complex mathematical puzzle. That mathematical puzzle needs to be solved. When they solve that puzzle, they're awarded a monetary reward, which then has market exchange. You don't need to do that if you have someone in charge. So it's no one, when you give it a database to a corporate, you say, what do you want from your SQL database? Oh, I want it to give me money. No, a SQL database, when you use it, is there, and you use it because it is useful and it performs a useful function. So you can change your security model in accordance with what the needs of the application are. And I don't think Bitcoin solves any particular commercial problem well. I'm going to throw it out and say it, unless you're a libertarian, and I am a libertarian. But the problem it solves is being Bitcoin. That's a very specific problem. I don't think we should take the approach that that particular network is going to be the end-all and be-all of human existence. It was, as one of the speakers said this morning, a test case for blockchain. It's good at being what it does for people who want it to be what it is.
One of the, sorry to interrupt, one of the speakers, yes, I can't remember who it was, put up the slide, and I can't remember, I'm paraphrasing slightly, but I think it said, idiot dick Facebook twins support, lunatic currency or whatever.
Oh yeah, that was Jeffrey Robinson.
Right.
Yeah.
So, I just want to push you on that a little bit, because you made quite a strong statement, and I'm interested.
Well, I didn't want to hear.
Bitcoin, the currency, is that essentially already over? Is that essentially finished? It's not going anywhere.
I take a fact-based approach rather than a prediction approach to everything I do. On the basis of the facts, I do not think for very long that Bitcoin will be the only blockchain or the only useful blockchain in the world. I can't really extrapolate past that. It's good at what it does for people who need it to do what it does. That's all that matters. People should have the ability, in my view, to use whatever data structures they want to communicate whatever information they want, completely independent of third-party interference, if they would like, on their own terms and under their own control, instead of the control of a Google or an Amazon or a Facebook. So Bitcoin does that in terms of value for its own network. It's an application. It addresses a very specific use case for a very specific audience. That doesn't necessarily mean it's perfect for every other application and every other audience. That's my personal view on that. So you can engineer blockchain solutions very simply. This is a smart contract. We've got some guys who basically have set up a model to automate a bank or bank process. This is one of the angles we're looking at the moment. And so you have to ask yourself before you do that, though, does a blockchain actually solve the problem I have? Why not just use a server? If the answer is yes, as Vitalik said, when you have multiple parties who are currently running redundant software stacks in redundant places, you've got, let's say, a typical commercial transaction. You'll have two banks, they're law firms. Each one of them will hold copies of every single email, soft copies of every single document. They're storing more data than they need to really mediate what is, in effect, a very simple version control transaction. If you put that entire process, and you come up with a proposal for that we call Open Document Monkey, and if you can take that process and treat transaction negotiation more like GitHub and put it on a blockchain, all of a sudden you've simplified the data management. Speaking as a former junior lawyer, you've simplified the process of actually creating those documents, and you've simplified the process of verification when those documents are going back and forth between various sides. So that's a process which can be made more efficient with a blockchain between two organizations. So if you need to harmonize, blockchains are good for that. If you need to collapse a process into very simple logic, blockchains are excellent at that. Bitcoin is excellent at that. If you need timely verification, instead of relying on multiple human beings to verify and check that something has been done, a private key's been sent, that's it, it's happened. That, the verification, if that's paramount, you might want a blockchain. And if you want to reduce your supervision and oversight costs, if you want the thing to just run in the background, chances are you want a blockchain. Tending to know if it requires speed, you do not want the blockchain. Blockchains are actually awful at payments. I think that is the biggest red herring in the entire blockchain space. I don't know, and again, this is what happens when you get Silicon Valley to do banking. But blockchains are not very good at being payment systems. Bitcoin is not good at being a payment system. It is good at being a value storage mechanism for people who want to use it as such. That doesn't make it appropriate for global settlements. If it requires heavy computation, chances are you probably don't want a blockchain. Blockchains are passive. They respond to instructions. The users of the system or the nodes who are instructed to process those transactions are the ones who are processing. You don't want to increase that burden any more than you have to. And if the process is fully automatic anyway, you're not going to get the order of magnitude improvement you want. So again, a lot of payments processes are not really appropriate for this. However, again, Vitalik identified this, and it's a point with which I wholeheartedly agree. If you want to get secure, open standards of communication between multiple parties. So let's say you've got bank A, bank B, and you want to eliminate the correspondent banking model and just be able to do a peer-to-peer transfer. If they have an oracle sitting in the middle, which can authenticate state changes between those banks without necessarily knowing the content of the data on either side, a blockchain, and it will be an Ethereum derivative and not a Bitcoin derivative, is a very good thing to carry that function out. So, or hopefully an Eris derivative, but we're an Ethereum derivative, so vicariously we do like Ethereum. So we write the appropriate rules. Going back to this 1, 2, 3 structure. For a corporate structure, you need to have it be controllable in every respect. For rule 1, write permissions of any kind, public, private key. And then in 99.999% of cases in finance, you're not going to want it to be fully public. You'll run it on something like a VPN. Rule 2, as I said, cryptocurrency pretty much got this one right. And then rule 3, you need to be able to change any aspect of the system on command. You can't plug the data back in, but what you can do is add a transaction to the end, which tells everybody, ignore this transaction, it's no longer relevant, or change your behavior. The block time, instead of being 15 seconds, it now needs to be 30. Do that instead. You need to be able to reverse transactions. This is absolutely necessary. And then mining, in most corporate contexts, is utterly pointless. So although you will have mining to incorporate the transactions, you will limit who can mine. You will have 100 nodes that can mine. And if someone attempts to mine and they sign a block with a private key that is not authorized, that block will not get added to the system. So what do you do? Step, you design your application. This is something one of our devs is working on at the moment. I can see all the sort of sample code on the website. And then when you're done, you come to Mama, and that'd be Eris Industries. And when you come to Mama, now notably the tools are all there, the code's open source, and so you can do this today. You could do it this afternoon. In fact, I would recommend you do so. So you get the tools, 2 commands, and then 2 more. So the top is our D server, that's our client program. The bottom is EPM, that's our chain manager. Second one, you write your rule book and you roll your chain. So you just say, right. So let's go up here. This is a file called genesis.json. So public mine 0. That's it. Public isn't mining this chain. Set it, click a button, hash your Genesis block, you're off. And then what you do is you deploy your DApp or your distributed application. It's an application like any other. It displays in a web browser. This here is before we actually got the distributed YouTube type app running. This is when we were hooking into YouTube's API. But our first demonstrator, it's a tech demonstrator. It's also open source. But it's available now. It's called ToGather. It's basically YouTube, which has its logic run on a blockchain. The logic is run on a blockchain. Our client program has a module for a distributed file storage system called IPFS. And IPFS pipes in the streaming video. And then it also has a Bitcoin tipping button, which is sort of a Bitcoin payment function. So this is to demonstrate that the blockchain is just the logic. You're not throwing everything you need onto it. You're only using it to control the relationships between the users. And then what they can do is if they want to go use Bitcoin or Ethereum or IPFS or BitTorrent or whatever else they want to use, they write a module for it, they attach it into the client, and then they build an application which displays in a web browser, which does exactly what they have told it to do. And then you do it again and again and again and again and again until you get it right, because chances are you're going to screw it up on the first try. We don't really accept the notion that blockchains are only useful if they're a big sort of central heavy chain with very long-lasting data permanence and ossified rules. We think that they can be erected for very simple, very short-term purposes, a transaction, any kind of proceeding, whatever you want. If there's a process, and over the life of that process, you need to verify what's happening, and you need to automate it, you can do it. And if you can write it in code, you can put it on a blockchain. And that's that. Thank you very much.
So we've got half an hour now for questions, but perhaps I could just come in at the beginning with one, and then obviously we'll open the floor up. So in terms of the description that you've given of blockchain, of this kind of technology, there's been quite a focus in terms of thinking of it like a computing platform, storage and processing, right? And I think perhaps we can explore with some of the questions, how far you can go with that, because could you run Angry Birds on the blockchain or something? But my question is about identity, because a lot of what's talked about in the context of blockchain is the fact that certainly in Bitcoin, it's one of the key features is as an individual transacting on Bitcoin, I establish a private identity, and then the protection of that and the use of that identity, that strong identity, is really important in terms of the transactional aspect of Bitcoin. So perhaps you can talk about how you see identity fitting into this whole kind of notion, this whole picture of a distributed, decentralized platform.
I think one of the things about our platform is that we look at blockchains within a context. They are not standalone. This is not Borges' map of the world, which replaces the world. This is something where it lives in the world, it hooks into the world, it relates to real obligations by real entities who are identifiable, and they're using the blockchain as a tool to help reduce friction in whatever process or transaction they're attempting to interact with. So identity in this case would be something where a user is issued with a key pair, and then when they transact, one of our developers has an expression. A blockchain is the only place in the world where the absence of evidence is evidence of absence. And what that means is, you can be fairly certain when you transact the chain, and if you wait a couple of minutes or however long the blockchain is, that if you're putting something in, and then let's say there's an obligation, make sure in a half an hour that you look again, and that thing is there, and then you walk away. You can't then later turn around and say that something didn't happen. There's no risk that in that process, or there's a reduced risk, I should say, that within that process, that transaction is going to get corrupted or affected. So it's something where, one of two things happened when that transaction was submitted. Either that person did it, or someone got a hold of their private key and did it for them.
Right.
So that increases the threshold. It doesn't solve the problem. These aren't perpetual motion machines. They live in reality. So from our perspective, this is something which people can design interactive applications with, where they know that if a broadcast is coming, it's coming from that person, and the application won't change unless that command is given. But you still have the ultimate verification problem at the end. This just makes it a little easier.
Sure. Okay.
Yeah, I guess in general, if you want to have persistent relationships with people or with programs or any other kind of entities, you need to have an identity. That's basically what identities are for. It solves the problem of person that does thing X is in some sense the same entity as whoever did thing Y. So, and as I mentioned in my presentation, identity is something that these days just about every web application in the world uses. And problem is
uses badly.
Yeah, uses badly because it's not baked. It was never baked in as a sort of fundamental layer of the internet. And what we have is, well, we have Google that built a fundamental layer of the internet for us. And with Google, Google basically ended up being in charge of just about a whole bunch of people's identities. So with to some extent, it depends on exactly what kind of application you want. But like if we're thinking of blockchains as platforms that somehow help people manage their identities, and there's a bunch of different paths that you can take. Like one option is that, like in general, in a lot of these cases, the only thing that an application needs to do is it needs to look up, oh hey, look, first of all, figure out whether or not a particular person is authorized to send a message on behalf of some particular identity. If all you need for an identity is just a public key, then you have cryptography. Cryptography does that for you. But if, on the other hand, you're interested in having a bit more information, like what's the name of this person, what's just some basic data, maybe a link to the person's profile picture, whatever else, you could throw that onto a blockchain. And if all of it is on a completely public and global data store, then it makes it's something simple that just about everyone can very easily interact with. Or so the other gains come in when you actually get into the whole concept of reputation, and can you actually, in general, like we already have a whole bunch of reputation systems on the internet. Like we have things like Yelp and Urban Spoon and Google and so forth. Those are all horribly exploitable, by the way. So then we have things like Uber, and the part of the reason why. Part of the value they provide is also being a reputation system, trying to filter out good drivers from drivers that are likely to smash your skull into a window. And I mean, in reality, that happens. My opinion is that happens much less than people think. You probably shouldn't worry about it, but for some reason people do, and so we have to satisfy that prejudice. But that's. And the thing is, in those cases, what they actually manage to do is they manage to tie a particular reputation to an identity and to a particular transaction. So like, there's no way to just leave 500 bad reviews about someone by tricking a system. You actually have to be a customer of the whole thing, of the system 500 times. So now, if we think one of the benefits actually of using the blockchain as a payment system, and I actually do think that there are ways of getting around the timing problem, is that you actually have a global record that, hey, look, a payment happened. And if you can actually tie reviews to those payments. And you can actually make you can use cryptographic proofs to make claims about yourself. And those claims can even be something like, oh, look, I had 500 interactions. Look, here's a cryptographic proof that all those interactions actually had economic weight. So I'm not just some random guy trying to trick you. And with those interactions, look, I got positive reviews for a bunch of them or whatever else. And there's a bunch of really cool cryptographic tricks you can actually use that without revealing any information about yourself. And what you have as a result is basically a platform where first of all it's reputation with an API. And second, it's a sort of global thing. So it's something that any new service can very easily plug into. Because right now, if I'm gonna just come up and say, hey, I want to build a new sharing economy platform, you need reputation in sharing economies. But what am I going to plug into? There's a bit of a network effect problem. People start off being unreputable. Second problem is that they have a really huge switching cost. So if I want to make my own Airbnb competitor, and for people to switch to me, they have to basically give up their Airbnb reputations to a large degree. If that gets moved onto an open platform, it becomes much more portable, and switching costs go way down. So that's where I see some of the benefits of the extreme public and open.
That's actually a really important point. All of this, by the way, there's a great contrast between the two visions here. However, they're not mutually exclusive. Any state of data on any application being run in a private setting can be verified by reference to a public chain. And so that's a way that you can actually get, what's coming is you'll have, in my view, public chains which serve that public function, and then private chains which are running the majority of the logic, which you don't necessarily want to throw onto a public chain because it's an application with 500 smart contracts in it. Do you really want to throw all that onto an Ethereum?
Right, so it's one of the really important reference points that we need to have a record of, and everything else can happen to the side.
Bingo. And I mean, this is, you want to talk about decentralization. I think that's a far more compelling proposition where you have sort of satellite databases, each doing their own thing, and then public utilities, which are themselves decentralized, where the logic isn't necessarily threatened, but you can add verifiability by leaning a bit on the public chains themselves. So none of this is mutually exclusive. That I think that's an important point to keep in mind.
Okay, questions.
Very short question. How difficult is to verify though? I mean, you need to have cryptographic expertise to do that, which is not.
In order to verify a blockchain, you just need to download the blockchain software and and click a button to run it yourself, right?
But I mean, perhaps I can jump in here. I mean, you could ask the same question about any kind of software, any kind of software development for a normal consumer.
The claims you make, like to know, you need like a degree of expertise to do that.
There are maybe 40 good blockchain engineers alive. Tops. So I think the view that we're taking is there are 40 now. In a year there will be 400. In 2 years there will be 4,000. In 10 years there will be 400,000. So if the technology is as good as people like us think it is, then that problem will fix itself. It's just a question of skilling up.
But it's also a design problem as well. Like usability is terrible right now.
Yeah, it's awful.
I think also one of the benefits that more generic blockchain platforms provide is that, in general, the concept of can you actually trust the underlying blockchain software? People need to figure it out once, and then once people know that this particular blockchain software package is generally trustworthy, then you immediately know that you can just use that software package to just verify anything that happens on it.
Okay, go.
Not to out myself as a Reddit troll, but I mean it's quite popular these days to say I don't believe in Bitcoin, but I do believe in blockchain, and I think it's a little bit dangerous to make absolute statements such as Bitcoin is dead or cryptocurrency is useless. It's horrible for payments. I mean, and that there's some new, not yet launched business that will suddenly solve all these problems. I think there's an ad nauseum amount of businesses and regions and geographies and solutions that there are quite useful, and to a room full of practitioners who are being introduced to the topic, I think it's important to say that there's a stepping stone effect, there's the use effect, there's starting with a cryptocurrency and then moving on to something besides blockchain. So just, maybe opening up your vocabulary a little to understand that, there's a lot of current critical mass technologies that can be used right now by startups today or yesterday or 6 months ago, and that developers can start working with to actually solve some of these problems.
First of all, I actually have about 30% of my money invested in Bitcoin.
Wow.
So the thing is that, fact is, I actually do believe it has some probability of becoming a sort of gold-like asset, and if that happens, it'll do very well. So there are a few limited use cases where it seems to me where it makes some sense and fine.
Long run, but also short term and midterm are important time aspects.
Yep, I agree. I mean, there's definitely use cases. I mean, if the short term, it's more the censorship resistant stuff, and long term, it's more this other stuff. But yeah, I think it's that. What we're looking at here, I think, is the question of actually going beyond the currency use cases and what happens for everything else.
My view on that particular topic is somewhat more nuanced than the presentation gave away. However, the intent of making the point, to which there is some truth, is that the majority of thinking in Bitcoin and the majority of the advocates of Bitcoin do not present a nuanced and balanced view. So by acting as a counterpart or as a counterpoint on the very opposite side of the spectrum, the intent is to get people thinking about it and talking about it and discussing it. Of course, I think Bitcoin's interesting. I quit a big law job to do this for a living and have not slept in a year. So there's something about Bitcoin, and particularly Dogecoin, might I add, hooked me and pulled me in, and I do like it. However, the intent of this exercise is to act as the counterpoint so that we can actually find a balanced view as to what the function of Bitcoin going forward is going to be. So yeah, it is designed to stimulate thought here. You know, I'm not going to go into my views at length because it would take a little while, but yeah, that's.
I mean, you might be pointing out that the Ethereum platform was crowdfunded with Bitcoin in the first place. So your entire existence is based on the fact that people believed in the idea and they used Bitcoin as a payment network to fund the entire project we're talking about.
To be fair, we could have just as easily used Mastercoin.
Right.
You're glad you didn't know.
Vitalik, in your original presentation, there was a bit you skipped over. I noticed about validators.
Yes.
Are they like miners? Because you're also talking, you mentioned that.
So validator is a sort of generic term that I'm moving towards because, like, I actually think even in the context of public blockchains where anyone can participate in validation process and they're fully politically decentralized, like mining in terms of the specific process of having people repeatedly burn electricity in order to secure the network, I actually think it's kind of, you know, economically inefficient and environmentally wasteful and all that, and there's a bunch of better approaches for doing it. So and those generally involve signatures, or generally involve validators that are selected using some kind of economic mechanism. So
do you mean an economic mechanism? You mean to incentivize them to be validators?
yeah, to incentivize them to be validators, and specifically to incentivize them not to be bad validators. And so, like, in that kind of paradigm, like, validators are just a more generic term that captures it. You know, they could be doing any different kind of activities.
So are they critical then to the way Ethereum works, to have validators?
Well, so any blockchain has validators, first of all. It's the concept of, in general, by validator in this case, I define it as a node that needs to sort of sign off on a block in some sense in order for the block to be a valid extension to the blockchain.
So basically all the parties that are involved in the consensus decision.
Yeah,
right.
Exactly. Okay. So yeah, you know, if there is a consensus, there obviously have to be parties involved in the consensus decision, even if it's a consensus of one.
Yeah. Okay, go
on. Yeah, I think this is a question that appeals to me very personally, but I think this is the right audience to ask. Probably more to Preston than to Vitalik. Can you say something about, let's say I want to start up my happy fluffy club of bankers, and the compliance department or the legal department come back and say, okay, we need to exchange a whole bunch of contracts before we can get access to this thing, whatever it is. Before we do anything, we'll do some contracts. How would you see the evolution of contracts, standard legal contracts, documents, boring stuff like that, interacting with the blockchain that the Happy Fluffy Club is going to be working with? So
legal contracts and smart contracts, whenever someone says smart contract, forget lawyers. Smart contract is code. It is verifiable execution of code over cryptographically verifiable data. And so at the moment, I think what we're going to see, so we've got a system which we call legal markdown, which is basically just prose. And what you do is you hash that into a smart contract, which has totally separate payment mechanics. There's also Common Core in the States, who I think you know, Primavera de Filippi, and God, I can't remember his name. James has it, thank you. And so they're working on creating programmable contracts where you can actually have, you know, a sort of coded description as to what a particular provision means. So I think what will wind up happening, our approach is currently two separate things. We know what a particular process is going to do, and we know how to express that process in code in respect of data in a context. So let's say you're dealing with a payments waterfall in a securitization, you've got parties A through F. And so if there's 100 A first, then B, then C, then D, then E, and if you run out of E, then F doesn't get paid. So that will be a script. And then you'll have a prosaic set of terms. So our view is they're developed separately. I think in terms of where it's going to go, there will probably be a convergence over the medium term where you will simply be able to just click and select. And so a process will have, you know, a payment process. It's funny, when you do things like cash flows, there can be mistakes in where a comma is, which changes what happens with that payment under certain circumstances. I can't remember one specifically, but we had a very funny one which we built a lot of time on back in January last year, which was great. So, but I suspect what will happen is those types of provisions will be expressed more in terms of the data. And then what you will do is you'll say, right, this is this, and the prosaic legal term, which a judge or a layman uses to interpret it, is also standardized to reflect the flow of information in the context of the system. So I think there's going to be more code. It'll be very gradual. It starts separate, but then eventually you'll start marrying them up, and then the code itself will just have legal meaning because we'll know what the code is.
Also, I actually think that's the appropriate sort of industry that smart contracts are going to be replacing / disrupting / whatever term you want to use. It's not so much the court system, but private arbitration.
But isn't it the case anyway that, I mean, you take a kind of a simple example, an email with just my name sign on the bottom is a legally binding, that's a legally binding signature on that email. The problem is producing the evidence in court to
context. Everything is context.
And so my point is that the legal structures we have already should be able to account for all this. It's about putting the evidence in the right language, so that when you're in a court of law, as you said, a judge can make a sensible decision. So I think there's not mutual exclusivity here. These things can be
not at all. And I think the efficiency that the technology is going to allow is going to mean that the courts start recognizing the code as law.
Right. Have there been court cases yet around blockchain?
Not around. Well, only in the sense of sort of criminal proceedings.
Apart from the fraud.
No, but there have been. I mean, the closest one that I can think of that's a real world analog was a derivatives case called Frith-Rixon, which was decided, I think, in 2009, and that was a very obscure provision of the ISDA master agreement. I don't know which one, but basically there was a very obscure mechanical thing. I think it had to do with insolvency. It was the Lehman collapse. So I can't remember the facts, but you have those kinds of situations now where something which is effectively purely mechanical, all of a sudden you'll go through it, or post-enforcement call options. There's another case, Euro Sale 2006 3DL. And so that case, you had a call option which was exercisable in the event of insolvency. It was supposed to do whatever. Again, I haven't read the case in a while, so I'm not familiar with the facts as I'd like to be. But it was viewed by everybody involved as being purely mechanical in nature. It might as well have been a smart contract. But then all of a sudden, a set of facts arose which broke the mechanics. And so this will happen, I think, quite similarly in smart contracts. It'll take some time, but if it's efficient enough, then it could happen very quickly.
So your view would be that the smart contracts would refer back to the pros in some hashing sense?
Eventually, the smart contracts will become, I think the data primacy, what's supposed to happen, the intent of the parties, is the most important thing. So it doesn't really matter what the pro says. It could say, we want the blue dog to jump over the fence and talk to the happy marmot. We could do that. But if that's what it says, if the parties intended, you will deliver this note on that day, then that's the agreement. You just have really bad evidence of it. So I think the code itself is it's much closer to, it's a way of getting closer to the party's intent than prose, because prose is capable of sort of fuzzy interpretation. There will always be a range of discretion because prose exists in a fact pattern. But we're going to see code become much more important, I think.
Do you think that in the short to medium term, it's actually better to see smart contracts, not so much as being actual contracts, like that term never been used? It's more, I think it's more appropriate at this point, just view them as a sort of sui generis thing. That's like, hey, here you can throw money into a program, and the programming language has the ability to control money.
And considering we know all the people who write them, then I wouldn't recommend their use in business extensively.
Yeah, I've also come across this term, digital or autonomous company. What's that?
That's one of those terms that everyone has a completely different definition for.
I mean, legally, it's bullshit. But basically, a DAC is an autonomous agent which has certain rules over a certain set of data, which is expressed in smart contracts, where anyone who's using it knows that if they put in a certain input, they get a certain output. What that means legally, there's a range. If you say it's a company, no, because a company is a company by reference to its incorporation, jurisdiction, blah, blah, blah. If you want to do something like it's a partnership or an unincorporated association, that could happen, depending on what it does, who's involved in it, and what the rules are, and what function it performs. In the very basic sense, it's just code. And then whatever meaning it has is really dependent on what it does.
So it's a reincarnation of an existing concept of this agent thing.
It's a view. It's nothing now. It's a glimpse of what could be.
Okay.
You say that the blockchain is low. When we think about the applications on some programmer running on the blockchain, should we think about an application that does not need to write data so quickly, or is it a temporary problem, or is it something by design? Like, for example, like in Bitcoin, I mean, the settlement is some way slow by design. Or we can expect that in the future it will not be a problem to write something that is permanent.
So I think what the question is I'm not quite sure what you're asking. So
The question is when I'm thinking about an application that should be run on the blockchain. This application should not have requirements to write things very quickly. For example, if I'm thinking about exchanging shares or something like this, for which it's very important also that the settlement is quite quick. Maybe the blockchain is not the right.
It depends. Like, first of all, Bitcoin is very dated technology. 10 minutes is not even close to the best that you can do, even in regards to whether it's a decentralized or a centralized concept. Like, I fully believe that it's quite possible to have decentralized blockchains with under 30-second block time, and we're targeting 12 seconds right now. The very minimum is that it has to be at least like maybe 5 or 10 times network latency. If you're going below that, then yes, a server makes more sense.
I mean, I think for something like derivatives settlement or any kind of settlement, right now it's 3 days. So if it takes you 10 minutes to get confirmation, great.
But that's because of the layers of custodians and all the intermediaries that exist in the marketplace, right?
Exactly, and so it's taking this process, which currently has a lot of institutions, people involved, and just going, this is now logic, which we can identify to know the rules. So for something like that, where you have multiple parties, multiple stacks, a lot of human beings, and you want to cut costs, blockchain, super, and that's the kind of thing where it's the sweet spot. If you're dealing with high frequency trading, where even the speed of light is a problem in some cases. If you want to do high frequency trading, you're in New York and the exchange is in Hong Kong, you're going to lose because it's going to take you 40 milliseconds to get a round trip transaction. So even assuming that the universal maximum is being hit. So for that, do you really want a distributed network where it's, I'm going to solve this little puzzle? Okay, great, guys. Hey, here's six of my buddies. Here's a solution. Go get 6 of your friends.
Surely what matters is everyone plays by the same rules. So even if the trades slow down, so long as everyone's playing by the same latency, then it's not a problem.
But you can't.
But there is a very substantial movement in favor of deliberately making markets sort of slower and have like execution be done in batches, specifically in order to remove those kinds of advantages. And that's worth.
I mean, ultimately, we use servers to verify stuff. Sorry to jump in, but we use servers to verify things. So we use blockchains to verify things. The question is, where's the blockchain going to be better than the server, given the context of what we're attempting to do? Not everything, certainly, but some things definitely.
Ed.
Yeah, thanks. Quick question, Preston, about my understanding of the solutions you're providing. You said there'd be no mining, so I understand that you wouldn't necessarily need the rewards and the payments, but who would actually be the validators of, let's say, a block shared by a group of banks?
There is mining, but the mining is restricted to certain validators, so you can set the difficulty in advance, so you don't need to make the problem harder than it is. And then what happens is if the validators, let's say you've got nodes 1 through 100, and they all have their key pairs, and so nodes 1 through 100 are able to sign blocks and add those blocks to the end of the chain. If 101 decides to hop along and sometimes it's a copy and tries to add a block to the end of the chain, boom, he does it. And just like with Bitcoin, if you try to spend a transaction if you haven't got the private key, you're just throwing data at the blockchain and it's not responding. So similarly, if you attempt to add the block, the other nodes will go, what the hell are you doing? Look, get out of here. And then that's that. So you can't add a block unless you can give it. There are tiered permissions.
So who would actually be those nodes? That's what I'm asking.
The developer chooses them.
So you'd pick maybe, I don't know, if you had 5 banks, you'd have 20 per bank or something like that.
Whatever makes sense in the system design. I mean,
would that not allow 3 banks to then gang up?
Yeah,
and if you're concerned about that, that's what you need the public blockchain for.
Then the other banks who are misbehaving get the living daylight suit out of them by the banks who didn't. So this is the ultimate backstop. All as a macro for security.
So this is about networks of entities working together.
Correct.
And so obviously they have to balance those things. I think it's also useful perhaps to separate out the concept of ledger, which is about history and transparency, from the concept of the mining, which is about how to
incorporate transactions into blockchain.
And that's about kind of resiliency and trust, isn't it?
Mining is not even about incorporating transactions into the blockchain. Like there's the process of forming a block and the process of mining are actually completely separable from each other. All that mining is mining basically means that once you have created a block, there's one piece of data in that block that you have to like keep on trying different values for until the block satisfies some particular mathematical property. And the only reason that exists is in order to make it artificially hard to create blocks. And that kind of makes computational power a proxy for the extent to which you can participate in the system. If you either do not need to restrict it by computational power, and you instead just say, oh, you know, each one of the members in our Happy Fluffy Club can produce blocks sequentially, then you don't need to have the mining. You just say, okay, if you create a block, then you add a signature to it, and that just makes the block valid by itself. And you know, if you
although you'll need to have something in there. So if all 5 entities are trying to write add a block in at the same time, there needs to be some orchestration of that.
Well, that's just that's just standard Byzantine fault-tolerant consensus theory, which people have been thinking about since 1982.
Right.
You know, people think that Bitcoin's proof of work is this big fundamental discovery in Byzantine fault tolerance theory. No, it actually, as there's been a couple of academic papers that actually show that it doesn't even improve on the fundamental bounds.
Right.
Like the contribution that that Satoshi made with Bitcoin, I think, is basically the contribution, the idea that if you simultaneously bootstrap a distributed consensus network and an economic platform, then those two can sort of form and grow more easily simultaneously because they both feed into each other. The economic platform incentivizes fully distributed consensus because, you know, if you have a fully open platform, then you need to use economics to regulate it.
Okay, go.
Just coming back to the application question, you mentioned that blockchains are particularly useful when you have multiple processes that could be consolidated in a single one. So immediately what springs to mind is something like supply chain management, where you have 2 different parties essentially doing the same thing but mirroring each other. Would you see blockchain being useful in that context, and would that be
it already is.
And skew chain.
There's
like
like
2 groups already.
And we've spoken to another group of guys who are doing it. We're not going to say they are, but there are a number of projects that are looking at blockchain to do supply chain management. Initially with things such as intellectual property for, or a widget. When an oil company has IP licensing for a particular widget, and BP goes and gives it to Shell as part of
So
who runs that blockchain?
It could be the public one, or it could be some specialized one. And also, by the way, speaking of supply chains, there's one actually interesting use case, I suppose, is the sort of digital version of a supply chain, which is open source software development. I have a software package. That software package depends on 3 other packages, and each of those packages depends on 5 other ones. So one question is that particular software package secure? So, you know, generally no particular company is going to be able to be able to pay for a security audit of everything that goes downstream for what they're building. Now, on the other hand, if you can somehow create a blockchain-based system that involves like companies that provides when they do an audit on some particular package and they provide a certificate for it, then all of a sudden all the information gets sort of work together.
Isn't Google trying to use a blockchain as a certificate authority?
I don't know. I mean,
I heard there were some rumblings. Yeah.
So the other interesting idea that I've come across is the idea of digital representations of physical goods. So if you can find a way of digitally, uniquely, linking to a physical object, then on the blockchain that might assist in providing, helping with the provenance of that. So a good example would be, the source of beef, through the supply chain of beef. That really would be
an important thing to note is that it is not a magic solution to every problem in the supply chain. I very frequently use the example, and I will use it again here, of a marmot, which is a fat rodent that lives in the mountains, and attempting to deliver a marmot in accordance with a delivery order. And when you deliver that good, there are qualities about it that, for example, it has to be fat, cuddly, and friendly. And if it isn't those things, if it's emaciated, hairless, and grumpy, all of a sudden you've got delivery of something, but the entire contract hasn't been moved in. You still have the entry point, the exit point for that transaction, which need to be gated and need to be monitored. So the question is looking for the efficiencies in the process of getting the cuddly critter from A to B, but not necessarily in what the qualities of that object are, because the blockchains aren't very good at that. So this isn't like magic, everything will be blockchainized. There will always be discretion on the way in and on the way out.
When I describe blockchains as magic, I suppose the thing that I was specifically focusing on is that you don't need to, in the public blockchain case, you don't need to really care about who runs it or whether or not it will continue existing. So it's a magic decentralized computer. It's not a magic decentralized God agent. And if you're a developer, then you'll probably know the specific ways in which a computer falls short of being a God agent. Hopefully.
Sorry, just on that note, the public blockchain, by its very nature, requires people to continue to propagate it, otherwise it disappears. So it always needs someone to be running it, or preferably a group of people.
But
so
you as a user,
you
as a user generally, you can assume that if there's thousands of people that are using it, then at least one of them will almost certainly keep on using it. So
if you place like MySpace, I know it's slightly different, but if you look like something like MySpace destroyed by Facebook, I assume at some point Facebook will disappear as well and be replaced by something else.
MySpace are they still around, by the way?
Let's find
Yeah,
out.
they are, but there's something very different. It's like a music sharing platform now.
Right, I remember. I think I might have gotten an invite a year ago or something. But in general, so the thing is that with MySpace, I mean, even if they had stayed as a social network, chances are there still might be like 100 users that care about it. As long as the number of users is greater than 0, the application keeps on going. And with the way that you could design your application in such a way that the fewer people that are using it, the less resources it requires, and so it kind of scales down to some degree, and that's fine. On the other hand, with the MySpace, I presume the original social network functionality is like not available anymore. So if it isn't, then that's one of those reasons why decentralized services are useful, because that it is going to still keep being around, and if something depends on it, it's
But so I want to bring up the magical thing, like the idea that the user doesn't have to know how to use it or what's happening. I think like Nigel Dodd talks about this as well. Just like maybe we should actually know how these systems are running. Maybe I do want to know who's running my public ledger, because isn't that like sort of the banking crisis all over again?
Do you want to know what's going on at the back end in Facebook? Do you want to know what's going on in the back end of any other
Actually,
application?
yes, I do want to know what Facebook is looking at and who's selling my data.
I think to some degree, the history of social progress is a history of people being able to use progressively more and more complicated things without understanding how the whole they work.
However, there's just one technology that everybody's using, and all of your supply chain Fluffy Cup members are all using the same system. It would be like if everybody on the planet used QuickBooks. So although it's complicated and everybody hates accounting, the accountants would at least have only one software to learn. So you actually, as more developers get into place, you would actually have more transparency into it.
These things are displaying in JavaScript now. I mean, this is not in a web browser. That's what both we and Ethereum are attempting to do. And so it's designed to fit in very neatly with the current way that people interact with data. So in a sense, you say, oh yeah, well, I know there's a blockchain there. You won't see it, you won't feel it, you won't touch it. You'll interact with it, but it'll feel very much like everything else.
So I think of this a bit like email. So if I send an email to you, I have no clue how it's going to be routed across the internet. It could go through any number of different servers along the way. Okay, and so I don't understand how it works. And if I did, it would necessarily restrict it. It would lose its utility. But there are ways that there are things that I can do to make that email work better. And I think that's the whole point. You have a platform, a layer, and as long as the properties of that achieve what you want, in terms of privacy or transparency, whatever other properties you need, that's what you need.
Carl Sagan said, if I had to memorize all of the chemical interactions that were required to digest an apple when I eat it, I would probably starve. So this is the principle on which we operate.
I mean, sure, but it doesn't mean that a human can't understand it, or that we shouldn't try harder. Like just because you don't understand how email works doesn't mean you couldn't.
No. If anyone wants to be a blockchain hobbyist, I am fully in favor of that.
I guess my point was it in the email example, you can do things like you can use PGP or you can encrypt. You can do other stuff over the top of the underlying infrastructure, sort of, to satisfy whatever your objectives are. It's about layers and making sure that you understand what level you're operating. We're running out of time. Let's have a couple of last questions, maybe.
Yeah, Preston, you said you're a libertarian, and you were saying there that blockchain doesn't solve problems. Can you be more specific? Because if you've got 2 billion people, say, in the world that are unbanked, then the blockchain, you can use a cryptocurrency, don't have to be Bitcoin, but any cryptocurrency, that solves the problem for those 2 billion people to get onto the network.
You think it solves the problem, but it actually doesn't. What it's really just done is expose those 2 billion people to price volatility in Bitcoin. So what
not necessarily Bitcoin.
Well, but if you use blockchain tech more generally, I think that if you have an administrator and you have a more complex system, which, for example, carries out a Hawala function or some kind of asset-backed lending in accordance with Islamic financial principles, or something like that, where you can script it more comprehensively, and you can get a bank projecting that data layer into that particular area at very low cost, that is where you're going to get, and this requires design work. It's not simply a question of saying we have cryptocurrency, therefore the unbanked become banked. What they need is a bank or something which performs a financial function. But if you want to bank the unbanked, give them a bank. And if you want to give them a bank, what's the problem? The banks do not want to go to the 75% of the world's population that they currently do not service, and they don't want to set up a building, put in some hardware, and get a bunch of IT employees who do not yet exist in a developing economy. They need a secure way to communicate with those people. Blockchains, in my view, probably the best way to do that. So, but this is a question of building very complex systems that perform functions where ultimately you have someone at the top who is accountable and responsible for administering the system. Bitcoin can be a part of that, certainly, but in terms of the complexity of financial, I mean, in Africa and Asia, it's not like, oh, we just have no money, and if only we had a money transfer system. No, they're very advanced, complex, and multi-layered economies, which have a huge amount of complexity in them. And so, yeah, it irks one of my business partners. In fact, he wrote a blog post about this 2 days ago, and it irks me when people say cryptocurrency will save Africa. It won't. Banks, a market infrastructure will save Africa.
People need to really go down and understand it's not. You need to go beyond just thinking, oh, people are unbanked, therefore there is some particular concept of a bank which will solve everything. It's more about you have to really dig down and figure out exactly what financial services are necessary. There's a report called The Poor and Their Money back in 1995, which talks about a bit of their stuff, and it talked about a bit of this stuff, and it described how people did not even have access to basic, decent ways of storing their savings. So that is already a problem. People there are literally just paying other people in villages to hold on to their money for them. If you can beat that, then great.
I mean, and equally, there are other issues that blockchains could solve here. It's not just the unbanked. There is no title registry. So a family will die, or the parents will die of HIV, and then what will happen is the children will inherit a house, except the uncles will come and they'll throw them out, and then they'll be out on the street. Family inheritance rights, a huge issue, particularly when you get gender involved. Setting up these registries is something which is currently beyond the capacity of most civil society organizations and government bodies in developing countries because they simply don't have the resources. Again, if you can script those functions on a blockchain, all they need to do is run a few nodes and you get a data layer which performs, again, it collapses the logic of a government system, and our governments could use it as well. So take these relationships, express them in code, build data infrastructure, and then you create the conditions, if you study it well enough and know what you're doing, that promote economic growth.
Yeah, on the land registry point, actually, at some point they talked to a lawyer in Ontario, and he pointed out that even in Ontario, a province in the wonderful country of Canada with GDP per capita over $40,000 a year, you have
impoverished socialist republic to the north.
Yes, the way the land registry works is, you have the government contracted out to some company which maintains it, and that company basically issues keys to lawyers that have a particular kind of license. And you have a lot of instances of people actually pulling off a scam where they figure out some way of getting a fake key, and then they use that key to transfer a bunch of houses over to themselves. Then before the system can even figure out what went wrong in reversal of those transactions, the guy just takes out a mortgage on all of those houses and then runs off to the Caribbean and there's a vacation. So
anyway, on that positive note, we are kind of out of time. So I think what we'll do, I guess you're sticking around, are you?
Yeah.
Let's give Vitalik and Preston a big round of applause. As I said at the beginning, there's another session thinking about the applications of some of this stuff later on this afternoon. So carry on there. We can kind of keep the discussion going. Thanks very much.
Hello everyone, can you hear me? Thank you very much for tuning in. I am at tomorrow's transaction forum in London. That was kind of an impromptu live stream that we did because Preston was like, oh, you know, Isabella can't make it to see my presentation. Isabella's like, was there a live stream? So we just thought we'd go live. So thank you very much to all the 30 people that were tuning in. There's also links below to Vitalik and Preston as well on their various projects. And don't forget, if you haven't already, please support our latest crowdfund for the latest app that I'm working on called ProTip. The donation address is down in the description below. I will see you all later. Thanks very much.